Hey everybody, is it that time already? It's the final video of this chapter. Well, we're going to start this chapter. I just want you to recall these three rules we talked about in the last video. There was the off-ball principle, there was the Pauli exclusion principle, and then there was Hund's rule. You can feel free to pause it and just look at them really quickly, or you can rewind it and look at it later on if you would like. But we're going to use these same rules like we did last time in the last video during this video. But today we're going to talk about something called electron configuration. It's a little bit different than orbital notation. You're not going to be drawing so many up and down arrows, so that becomes a little easier. Same type of idea, just done a little bit differently. Basically, what electron configuration is, it consists of an energy level, the cloud shape that it's in, and then the subscripts indicating how many electrons are in that shape. Instead of writing like 4 arrows, we would just write the number 4. The one thing I really want to point out, though, is right here. It says when you add up the subscripts for the element, when you're all done with it, it should match the element's atomic number on the periodic table. So it should match the number that it is on the periodic table. So when we do oxygen, we'll see that the subscripts should add up to be an 8, because oxygen is number 8 on the periodic table. Okay, now here's how I'm going to do these. I'm going to do a whole bunch with you. I think in total I'm probably going to do like 30. Hopefully after like number 10 or so, you will see that you will see the pattern start to come into play. Okay, so let's give this a shot here. I'm going to start with hydrogen, and we're going to do hydrogen's electron configuration. Now, if you guys look, it is in the 1s column, so I'm going to do 1s. But instead of doing arrows like we did last time, I'm going to just represent it with a subscript, or actually a superscript. We're going to write it kind of up like here, and we're going to put 1s1. This is supposed to be a 1 here. So 1s1, that is hydrogen's electron configuration. 1s because that's the block that it's in, and 1 because it has 1 electron. Let's try helium next. Helium also in the 1s block. So I'm going to put 1s. But helium, its number of electrons is 2. That's why we had 2 arrows last time, and we're going to represent it with a 2 superscript this time. When I do lithium, you got to remember, Aufbau's principle said start at the lowest possible energy first, then move up. So lithium, I have to do 1s2, then I do 2s, because that's where lithium is, 1. Now if I add up these subscripts, or superscripts, 2 plus 1, that equals 3, and lithium is number 3 on the periodic table. So that's a good way to fact check your work when you're doing this. If you can make sure the superscripts add up to the number that it is on the periodic table, you know you're doing it right. Let's try beryllium. Beryllium is 1s2, then 2s2. 1s, because you have to start off there. You go through them both. Then you go to 2s, and then it's the second one over. 2 plus 2 is 4. Beryllium is 4 on the periodic table. All right, let's try boron. Boron starts the same as everyone else did. 1s2. Then we'll go 2s2. Now we move to the P section with boron. So I'm going to go 2p1. 2 plus 2 plus 1 equals 5, and that is what boron is on the periodic table. Now let's try carbon. Carbon, 1s2, 2s2, 2p2. 2 plus 2 plus 2, that is 6, that is carbon. If you want, you can feel free to pause the video right now, give these ones a try, see if you can do it. If you don't feel like doing that, we're going to do them all right now. Nitrogen, I start 1s, 2, 2s, 2, 2p, 3. It's the third one over in that p block. Oxygen, 1s, 2, 2s, 2, 2p, 4. Adding up those subscripts, I get a total of 8. That's the number oxygen is. All right, 1s2 for fluorine, 2s2, 2p5, because it's the fifth one in that 2p block. Lastly, I have neon, 1s2, 2s2, 2p6. So hopefully you see the pattern starting to assemble. I always start with 1s. Once 1s is filled, remember I can only hold 2, I bump up to the 2s. Once that is filled, I bump up to the 2p. 2p, I go all the way up to 6. Let's try some more. Again, if you would like, feel free to pause the video. You can try filling these out on your own, see if your answers match mine. If not, feel free to write a comment or email me if you need some more explanation on it. Just let me know. All right, let's try sodium. Sodium, again, I start with 1s2, 2s2, 2p6. I go through all the ones that I just did. Now, sodium is in the 3s section, and it's the first one over. 2 plus 2 plus 6 plus 1. That'll give me a grand total of 11, which sodium is. 1s2 for magnesium, 2s2, 2p6, 3s2. See if we can go a little faster. Let's try aluminum. 1s2, 2s2, 2p6, 3s2. I'm going through all the ones I went through. Now I have to jump over. I'm going to go to the 3p section. It's the first one in that column, 3p1. Let's try the next one. 1s2, 2s2, 2p6, 3s2, 3p2. Pattern continues. We're just writing it as we go. Always start at the top. Once you fill those, you go over to the next one. Once you fill that, you move on to the next one. Eventually, you'll be able to just do this kind of without thinking about it, because you really just have to follow the pattern that you've already set for yourself, and you can just keep going, adding that one additional one. Now, I will tell you, people always try to do this. They always, when they're doing these, they're like, oh, well, you know that I'm going to do the 1s2, 2s2, 2p. So they try to add those little, repetition things, and they try to not write all this stuff. No, can't do that. You got to write out the full thing. If I can write out the full thing, you can write out the full thing. Okay, let's try a couple more. So potassium, 1s2, 2s2, 2p6, 3s2, 3p6, and then we jump down to the 4s1. Okay, last one here, 1s2, 2s2, 2p6, 3s2, 3p6, it's supposed to be a p, and then 4s2. Okay, hopefully you understand the pattern there. If not, send me a message, send me a comments. I do have a few more things I want to show you in this video, but this is definitely the bulk of it right here. Electron configuration, basically the same thing that we did with orbital notation, but instead of doing those lines with the arrows, we just write the 1s and then represent with the numbers now, the 2, 2, 6, with the, instead of drawing the arrows. Okay, Now, I know your hands are probably hurting, which is good because there's a shortcut. I'm going to show you the shortcut right now. All right, here's the rules for the shortcut. You're going to write down the most recently passed noble gas in a bracket. So an example of that would be like HE, that's a noble gas, putting it in a bracket. Or neon, that's noble gas, you're going to put it in a bracket. And then you're going to start at the next available line. For example, potassium, the one that we just did, I would represent that by putting argon in a box and then 4s1. That is the next available line after I am done with argon. So let me first do the longhand version of potassium. I know that we just did that. That was 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Now, why am I allowed to change this all the way to AR in a bracket and then 4s1? Well, here's why. The electron configuration for argon is 1s2, 2s2, 2p6, 3s2, 3p6. So instead of writing all this out right here, we just represent that with argon in brackets. You can only do it for noble gases. You cannot do it for any other element. So it's only for noble gases put in the brackets, not any others. Okay, I want to just try doing a couple shortcut ones here with you, and then we will be good to go for this video. The first one that I want to try is calcium. So you have to find where calcium is on the periodic table. It is number 20. We're going to write down the noble gas that it most recently went by, and that is argon. So I'm going to put argon in a bracket. And now I'm going to be able to start at my next available section, which is the 4s section. And calcium is the second one in that section, so I'm allowed to just put 4s2. Let's try zinc. I'm going to try to see which noble gas zinc went by most recently. Again, that is also argon in this case. And start at my next available line. I'm going to go 4s. Got to go through both of those. My next available section is the 3ds. And I count over. Zinc is the 10th one in that section. Let's try bromine. Bromine most recently passed argon. Put that in brackets. Then I do 4s2, 3d10. And last but not least, now I'm in the 4p section. I count over, and it's the 5th one in that section. Let's try barium. I have to find where barium is on the periodic table. Barium is number 56. It most recently went past xenon. So I'll put XE in brackets. Start at the next available line. That's the 6 S's. So I go 6S2. Now that's a lot easier than writing out the original for barium, which would be this monstrosity that just keeps going and going and going forever. So the shortcut is very, very beneficial because then you don't have to worry about writing all of this endless junk. You can literally just turn it into this. I guess I'm committed to writing this fully out now just to show you how long it would be without using this shortcut. So this right here would be the longhand version of barium, and nobody really wants to do that, so we normally just use shortcuts when we get pretty low in the periodic table. Okay, let's just do the one last one. Let's do gold here. Gold, same noble gas as before. XE, put in the brackets. I start on my next available line, which is the 6 S's. Then I go down to the 4F block. I have to go through all 14. Then I jump back up and I do the D block, and it is 5D9. Okay? All right, so that's the electron shortcut. Figure out which noble gas it most recently went by, put that in brackets, start at the next available line so you don't have to write out ginormous things like that. That's just you. Nobody wants to do that. Okay? My very last thing in this chapter to show you is, can I give you a electron configuration and can you determine which one it is? Of course you can. It's actually very easy to do it. All you have to do is just look at the very last version or last part of your electron configuration. For example, this one, I would go to the 2p section. I would count 4 over, and this one would be oxygen. If I gave you one more, let's say I had 1s2, 2s2, 2p6, 3s2, 3p3. I'm trying to figure out what element this would be. I would look at the very last portion of it, which is the 3p3 portion. I go on my periodic table, I find the 3p section, and it is phosphorus. Okay? Now that is chapter 11. You can feel free to watch these videos as many times as you want. You can rewind them, you can pause them, you can do whatever you want. You can email me, you can Twitter me, or tweet me. You can leave comments on these videos. Yeah, anything really to help you guys, I'd be glad to do. Using these videos for chapter 11, you should be able to finish that packet. Feel free to turn it in when you're all done. And then there'll also be videos for chapter 12. And then that is it.